Hey guys,
Hey
welcome
guys,
back to my
welcome back to
channel.
my channel. Today we are going to talk about the two protocols that run on the transport layer. As I had mentioned before, we have an OSI stack which runs on all the networking devices. This is basically a software stack, and it has say four layers. Okay, the fifth layer is the physical layer, and layer two is where we use the MAC addresses. This is the Ethernet part. Okay, layer 3 is where the IP address is used. Okay, and then TCP is the TCP protocol, which is this is a transport layer. You either use the TCP protocol or UDP protocol. So these two protocols are transport layer protocols. These are the most widely used protocols across the internet, and TCP is used even more than UDP. So, and on top of that, we have HTTP, FTP, and DNS. These are nothing but application layer, right? So these are the applications that you're using. So let's see. Okay, so let's talk about what is TCP, right? So TCP is nothing but transmission control protocol. Okay, it's basically it when two devices want to communicate with each other. The TCP protocol helps in establishing a session between them. Once that session is formed, it helps in sending of data from one device to the other device correctly and securely. So this is what TCP does. Okay, so this is a standard which is followed by all the networking devices, and it helps in communication between the two devices by establishing a secure session. Okay, now let's see what does the TCP do. So let's say I want to log on to a website, right? So I'm using the HTTP application over here. So HTTP application, so the HTTP layer, the application layer, it will create it will create a packet and it will populate the data. Okay, whatever data it has some HTML data, it has some HTTP request packet if it wants to send, right? So it will populate all those information. We'll read about HTTP when we talk about HTTP protocol, like what all fields are there in that packet and what all needs to get populated and what would be the data be like, right? But now what application layer would do is application layer would create that packet which will be the data. Okay, it creates the data and sends it to the TCP layer, right? The TCP layer receives the data. Now it will add its own L4 header, right? Then it will send to layer 3. Layer 3 will add layer 3 header, layer 4, and data. Then again it will send to layer 2. Layer 2 will add its own header, then it will have layer 3, then it will have layer 4, and then it will have the data. Correct? So what happens in TCP? What all fields are there in the layer 4? Okay, so layer 4 basically has source port, it has destination port, it has acknowledgement flag, it has a sequence number, and it has some flags. Okay, these flags can be used for different purposes where we want to modify the TCP protocol in a certain way. As the protocol adds more features to itself, they can use these flags to do various things. So this is used for that. So we are going to see about source port, destination port, acknowledgement, and sequence number, how these things work. So let's say we have two devices which want to communicate with each other, right? Now the TCP protocol receives a packet from HTTP layer, right? So HTTP, so let's say this is the TCP opens a port towards the HTTP layer, application layer. So each application runs on different ports because on the software stack there is only one TCP program running, but there are multiple applications that can run on it. So let's say HTTP it uses some 2000 port. This uses 2002. This uses 3000. I think we can have about 65k ports, and the first 1000 ports are reserved. So like now my source port would be 2000, and what would be my destination port. So now this packet has to go to the web server in order to fetch that web page. So generally on all the devices, web servers will be on port 80. Okay, so the source port will be 2000 and the destination port will be 80. Okay, and this is 2000. And we also have sequence number and acknowledgement. I'll tell you what it is. So let's say the packet is sent out, right? The first packet that is sent out will be between two devices, will be, this is the host A and this is host B. Okay, the first packet that goes out is a synchronized sync packet, or with a sequence number X. Host B receives this packet. It sees that okay, it's a TCP packet, it's trying to form a connection with it, and the host B is ready to form a connection. Let's say if it does not have enough ports to accommodate this connection, or for some reason it does not want to form a connection with this, it will send a instead of acknowledgement packet, it will send non acknowledgement packet, right? It doesn't want to acknowledge. Okay, but if it can form a connection, then it will send a acknowledgement packet. So that is ACK. It will also send its own ACK will be sent, and which will be with X plus 1. X is the sequence number sent by A, and it will also sends its own sequence number Y. Okay, then A will again send a packet, acknowledgement packet, with Y plus 1. Okay, so this is called a three-way handshake. So once this three-way handshake is completed, after that only the data will be sent. Once the data sending is finished, then A will send a packet called fin, and B will acknowledge it. Then B will send a packet called fin to A, and A will acknowledge it. So that's 4 times, right? So that's a 4-way handshake. So to form a connection, it's 3-way handshake. Then the data will be sent. Once all the data is sent, then the connection is broken by sending a fin packet. Okay, and that is 4-way. So A sends fin, B will send ACK, B will also send a fin, and A will send ACK. So in TCP, remember, acknowledgements are very important. For every message that is sent out, there is an acknowledgement that is being sent out. Okay, this way it makes sure that the connection is reliable, the data that is transmitted is free of errors, and it does not get lost somewhere. So what happens if I don't receive an ACK? I will send that message again. Okay, that's how the TCP makes sure that the connection is reliable and it is secure, and also that data is being sent correctly, and retransmission can also take place. Okay, so this is how the TCP connection happens. TCP connection is broken down and the data is sent. Now TCP also has this job of, let's say the data, right? This is 5k byte packet. Okay, but generally the Ethernet, right, this can only send about 1500 size of a packet. So what TCP has to do, TCP has to divide this packet into multiple packets. Okay, so 5k byte of data is given to TCP. Now TCP is responsible for dividing these packets and sending these packets one by one to the host B. Host B receives this, and then it will again rearrange the packets into one and send it to the application layer on the source port 80. Okay, and while sending the data, it will send, host A will send the data with the sequence number of the last data it has sent, last byte of data it has sent. So say it sends something, it says that 500 byte of data is sent, last byte is 500, and we will receive an acknowledgement for 500. Then it will send again 500, that is 1000, right? Then it will again send 1000 acknowledgement for 1000. In the sequence number, it will populate that particular value and it will send it out. Let's say I don't receive this 1000, right? What happens? It will wait for a certain amount of time. Okay, if it hasn't received that acknowledgement after a certain amount of time, it will resend it. Okay, and it will resend unless the connection is broken down. Yeah, it will resend. So in the software, right, as a software developer, you have this hold time and hello timer. So basically you will wait for certain amount of time, and if you don't receive a packet for that amount of time, you will resend it. You will try to resend the packet maybe a certain number of times, 3 times or something, and then once, even after 3 times you don't receive any response back, then you just assume that the channel has been broken, the session has been broken, or there's some issue, and you stop sending it and you close the session. This is what happens in the software. As a software developer, this is what you would have to do. You would have to code. Okay, this would be the logic which will be used. So now we saw that the TCP is used for secure connections. It is used for reliable connections. It is used for sending of data. So TCP, what it will do is it will break the data into multiple data fragments and it will send it out, and then it will rearrange on the receiver side. Okay. Also, that there are like few other things like congestion control, right? So TCP does congestion control. TCP makes sure that the receiver is not overwhelmed by the number of packets that are being sent. So what it does is it will first start sending packets very slowly, and then it will exponentially increase the number of packets that are sent on the window. Right? It makes sure that the receiver is able to receive all the packets, and it is able to send the acknowledgement also back. If it is not able to do that, then it will slow down the process of sending the packets to the receiver. That is called congestion control. It's an algorithm that runs on the TCP. There is also called flow control, which makes sure that the sender is not sending more packets than the bandwidth they have. They'll have a certain amount of bandwidth, and they'll just send the packets which can be easily sent over the bandwidth. The amount of data that will send, that it should not overwhelm the bandwidth also. So that is flow control. So these are the two additional algorithms that run on TCP. So which is flow control and congestion control. So then there is retransmission. It's also secure, it's reliable. So all these are the advantages of using TCP. Okay. It also does error checking, and it tells the sender that this is some error in the packet, resend it. So TCP has all these advantages. So this was about the TCP protocol, which is the most widely used transport layer protocol. I'll share a link to get more knowledge on TCP protocol. Please do let me know if you have any questions in the comment section. Tomorrow we'll go through the UDP protocol. I'll make a video on UDP protocol tomorrow. So yeah, guys, do like, share, and subscribe. Thank you.